Hello students, now let us see the lattice enthalpy from the Narayana neet book. Okay, what is the lattice enthalpy and what is meaning of this? The amount of energy released when released when the required number of oppositely charged gaseous ion present at infinite distance comes close and form an 1 mole of ionic compound crystalline solid is known as lattice energy of the compound. So what is their meaning? What is meaning of these students? If you are trying to understand the meaning, they are saying that is ionic compounds are there. Okay, and how much distance is there? A plus is there and B minus is there. They are that infinite distance, right? What they are doing, they are coming close, okay, and forming that is A minus A plus B minus. This is the ionic compound. Okay, ionic compound, they are forming ionic compound. At that formation, during that formation, energy released, energy released, in the formation of this energy released, which is known as lattice enthalpy. Lattice enthalpy. So what is lattice enthalpy in a student? The amount of energy released when required number of oppositely charged gaseous ions are present at infinite distance, come close and form 1 mole of ionic crystalline solid is known as the lattice energy of the compound, right? So they are infinite distance are there, they are coming close and forming 1 mole of ionic compound. This is how much? 1 mole. 1 mole. So if they are forming 1 mole of ionic compound, so that is what is the energy will release. This energy is released is known as lattice enthalpy. Now let us move another point. Lattice energy is directly proportional to the product of Z plus and Z minus and inversely proportional to the sum of radii of cation. So how much lattice energy will be there, student? That is the product of cation and anion divided by the radii of cation plus anion, where Z is the charge on cation and Z minus is charge on anion. Okay, lattice energy is also calculated based on Born-Haber cycle, which is based on Hess law. So what is Hess law? Let us read out the Hess law. Hess law of constant heat summation. The heat energy released or absorbed in a process is same whether the process occur in one step or the several step. What is meaning of A to B is forming student direct, or A to forming C to D and then it is forming B. So energy will be same. Suppose here is E1, this process, this is E2, this is E3 and this is E4. So whether it is completing in one step or the multiple step, energy is same. So that is E1 is equal to what will be there is to an E2 plus E3 plus E4. So this is what is energy. You read out. The heat energy released or absorbed in a process is same whether the process occur in one step direct or in several steps. So this is Hess law. Lattice energy increase as cation and anion size decreases. Okay. So if the size is small, lattice energy is more. LIF, NAF and KF. So highest lattice energy will be there in the case of LIF. Similarly, LICF, LICL, LIBR and LII. So in this case, size of an ion is increases. So in this case, that lattice energy will also be decreased. Okay. So what they are saying, lattice energy is increases as the cation or anion size decreases. So down the group, that is size of the anion is increasing. So lattice energy is also decreasing. Okay. Next, greater the charge on ions, more is the lattice energy. So NAF, MgO, Ln. So here is plus 3 minus 3 more charge. So here is more energy. And here is plus 2 minus 2. So more energy. So this is the point for the lattice energy. Now let us see next point. Greater the lattice energy, more is the strength stability and melting point but low solubility. Means what is point, student? If the lattice energy is more, if the lattice energy is more, right student, if the lattice energy is more, the strength and stability melting point will be also high, but solubility will be low. Next point, when a cation or anion in the gaseous state interact with the solvent in the liquid state, energy is liberated. This liberated energy is termed as solvation energy. Okay, read out this point better. When cation and anion in the gaseous state interact with the solvent or water molecule in the liquid state, energy is liberated. Okay, this liberated energy is termed as solvation energy. So whenever the amount of energy released when the gaseous atom or gaseous ion is getting resolved in the aqueous solution in the gaseous phase, then energy is liberated, which is known as solvation energy. When the solvent is water, liberated energy is called hydration energy. The value of solvation energy depends on the size of cation. Smaller the ion, more is the solvation energy. Smaller the ion, more is the solvation energy. Okay. Now what is their properties of ionic compound are their physical state. Physical state. What are their? Ionic compounds are hard, crystalline and brittle due to strong electrostatic force of attraction. So due to a strong electrostatic force of attraction, student, what they are saying, ionic compounds are what, student? That is, they are very hard, they are crystalline, okay, brittle, that is if you are breaking it will break into, easily break, and due to strong electrostatic force of attraction. Okay. Now, attraction and repulsion. What is meaning of same charge ion? Comes near. Same charge ion comes nearer, so they repel each other. Okay. If the same charge ion is coming close, then repulsion will be there. Here you see negative charge coming close, so there is a repulsion. But here is negative, then positive, then positive, then negative, then positive. So attraction, and here is repulsion. Isomorphism, important point. Two compounds are said to be isomorphous if they have the similar number of electrons, that is similar configuration of their cation and anions are known as isomorphism. Okay, so same number of electron in the cationic and anionic species are known as isomorphism. Okay, they have similar crystal structure. They also isomorphous solids having similar crystal structure. For example, NAF and MgO are isomorphous due to similar electronic structure. So NAF you see 288 and Mg2 plus O2 minus, that is 2828. So what you will finding is, student, the same number of electrons are there. So they are the isomorphous. Similarly, K2S, CaCl2 are isomorphous. So here is K plus 288, S2 minus, that is 288, K plus 288, Cl minus 288, Ca2 plus 288 and Cl minus 28. So they have all the equal number of electrons in the cationic and anionic form, those, so they are isomorphous. Next is boiling point and melting point. So you read out the statement, student. Boiling point and melting point. What is meaning of this? Ionic compounds have high boiling point and melting point due to strong electrostatic force of attraction among the oppositely charged ion. So boiling point is very high and melting point is very high. Why? Because they are strong because of the electrostatic force of attraction. Conductivity, it depends on the ionic mobility. If the solid state, no free ion, bad conductor of electricity. In fused state, aqueous solution, due to free ions, good conductor of electricity. So conductivity order will be, that is what, solid state, then fused state, then aqueous state. Maximum in the solid state, then fused state, and finally that is maximum will be the aqueous state. Next, solubility. What is solubility? Solubility will be high the solubility water, polar solvent, high soluble, NaCl in water, more soluble. The Na plus ion gets associated with very charged O oxygen of atom. Means what they are saying, Na plus and oxygen atom is the negative charge, Na plus, Na is the positive charge. So what they will do is, student, they will get associated and form the associated molecule, so they will be dissolved in water, and Cl ion associated with the positively charged hydrogen of the water. So Na plus, here you see, student, what they are saying, this is positive and here is negative, so they are getting associated and forming this much of the molecule. Next, what they are saying, oxygen atom H2O gives its electron to Na plus, so this electron is oxygen atom. Okay, this is how they are forming. So that is this plus positive charge added with the Cl minus, and here is the whatever the metal are there, Na plus, with this Na plus, what is negative charge, no, negative charge will is getting associated. So two diagram are there, you can see here, with the positive charge negative charge will come, and in the second case, oxygen atom H2O gives the electron to Na, so their electron is giving. Now next point you read out. Hydrogen atom of H2O gain electrons from Cl minus. Okay. Hydrogen atom of H2O gain electron from Cl minus. Thus, charge on Na plus and Cl minus decreases with electrostatic force of attraction, also decreases with, which leads to free ion. Okay. Thus charge on Na plus and Cl minus decreases, and electrostatic force of attraction also decreases with which leads to free ion. The energy released due to interaction between solvent and solute is called solvation energy. If water is used as a solvent, it is called the hydration energy. Nothing is there in this point, student. The energy released due to interaction between the solvent and solute is called solvation energy. If water is used as a solvent, it is called hydration energy. So no point is there in to increase. That is easily, water means hydration energy and solvent is there is solvation energy. For ionic compound to be soluble in the water, hydration energy must be more than lattice energy, or lattice energy is inversely proportional to solubility. Hydration energy and solubility are the proportional. Greater hydration energy, greater will be solubility. Hydration energy of hydrogen atom 1 by H R plus 1 by R minus. R plus R minus are radius of cation and anion. Next, hydration energy mainly depends on the cation radius, because of the value of 1 by R is negligible, okay, in comparison to 1 by R plus. Down the group, both the lattice energy and hydration energy decreases if the decrease in lattice energy is greater than hydration energy, and solubility increases down the group, vice versa. So hydration energy decreases down the group, so solubility will be decreases. Nice, right, student? Now let us see what are the factor affecting the solubility, right? So first one is dielectric constant, the capacity of solvent to neutralize the charge of ionic compound. Okay, capacity of solvent to neutralize the charge of ionic compound is called dielectric constant. It is represented by E. So water has the maximum dielectric constant, that is 80. That is, methanol is having 35, acetone 21, okay, ethyl alcohol 27, ether 4.1, benzene 2.3. So maximum dielectric constant is there for water, means it can neutralize the cation and anion more easily, okay, compared to any other of the solvent. So dielectric constant water, the water, methyl alcohol, no, ethyl alcohol, acetone, ether and benzene. Ionic compounds are more soluble in the solvent, having a high dielectric constant. H2O is there, H2O2 have high dielectric constant, H2SO4 and H2, but these are not good solvent due to oxidizing nature. Okay, so H2O, SO4 and H2O2 is the oxidizing agent. So they have, they have low, dielectric constant, that we have to keep in mind. Size of ion. If you talk about size on ion, keeping the size of cation constant, the lattice energy decreases with the increase of ionic radius. Hence, order of solubility of LiX in water is LiF, LiCl, LiBr and Lii, as solubility proportional to 1 by lattice energy. In LII, covalent nature is more according to Fajan rule, but no hydration enthalpy is greater than lattice enthalpy. So LII is more soluble in water. Again, you read out, student. LII covalent nature more according to Fajan rule. So more covalent nature means lattice enthalpy will be no lattice enthalpy will be less. Therefore, LIL is more soluble in water. Okay, next point C. Keeping size of anion constant, the hydration energy decreases with the increase in cationic radius. Hence, the order of means if the cation is cation is increasing. Okay, see, so what they are saying in the group 2, that is cation is increasing and anion is same. So more the larger the size of cation, smaller will be the solubility. So that is hence the order of solubility MgSO4 will be keeping the size of anion constant, the hydration energy decreases. So this is the beryllium, magnesium, calcium size is increasing. So that is hydration energy will be decreases. Next, if size of cation and anion are very large, solubility decreases from top to bottom. If size of cation and anion are very large, okay, so very large is there, then solubility is decreases from top to bottom. So large size of the cation and anion means solubility is less. Okay, student. Next, solubility decreases in period as ionic nature decreases and covalent nature increases. So that is solubility of ionic compound in period will be decreasing order. Next point, polarization of anion. Polarization capacity maximum in pseudo inert gas configuration. Solubility 1 by polarization AgF, AgCl, AgBr, Agi. Polarization increases, covalent character increases, solubility decreases. So ionic reaction. If we talk about the ionic reaction, ionic compounds show ionic reaction and covalent compounds show molecular reaction. Ionic reactions are faster than molecular reaction because of free ions. When NaCl is added to AgNO3 solution, white PPT of AgCl is formed at once. So AgNO3, NaCl, NaNO3 and AgCl, white precipitate is getting formed. So this is what is all about the lattice enthalpy and hydration enthalpy and Hess law from the Narayana neat book. Thank you so much for watching, students.